Hello, hi everyone. Welcome to MPEDU channel. This is Rama Obrat, chemistry lecturer. Okay, in the previous video, we discussed about packing efficiency of solid. In this video, we discussed about voids in the crystal or voids in the solid. Voids are also known as holes or interstitial site. When we observe these words, voids, holes, or interstitial site, we can directly conclude it is an empty space. Okay, this is the empty space between the particle. Therefore, we should give the definition. The definition of the voids is voids in the solid state means the vacant or empty space between the constituent particles in the closed packed structure. The empty space in the between the particles may be atoms, molecules, or ions. That empty space is known as voids. And how these voids are classified? Voids are classified based on the structure or their geometry. The Based on the geometry, the voids are classified into two types. One is tetrahedral void and another one is octahedral voids. First, we discussed about tetrahedral voids. Tetrahedral void is generally termed as T voids. This tetrahedral void is tetrahedral in shape. The tetrahedral void is an empty space. That empty space is created by constituent particle. During the packing of the particles, there is a formation of empty space between the particle. That empty space is suppose in tetrahedral shape, then it is known as tetrahedral void. Very simple. Okay, the empty space between the particle is tetrahedral shape, then it is a tetrahedral void. Let us observe how this tetrahedral void is formed. And consider the particles are rigid spheres. These are the particles. The three particles. The first two are in horizontal plane. That is the first one-dimensional arrangement of the particle. Next, there is another layer which is in between the first particles of the first layer. So it creates empty space. This empty space is in tetrahedral shape, that is known as tetrahedral hole. It is known as tetrahedral holes or tetrahedral void. This void is covered by the next layer because particles undergo three-dimensional arrangement. So it is only two-dimensional. Exactly in front or the behind, there is a one particle. Yes, this one. It covers that space and remains a one small three-dimensional space that is in tetrahedral shape. It is known as T voids or tetrahedral void. We can observe in another angle. So these are the two particles. Then the third one, this is the first layer, what I shown in the first three spheres. So this is the three sphere in three-dimensional view, and the space between three particle is tetrahedral in shape. It is completely covered by the another particle exactly above these three particle. So this is the placement. Small empty space remains in between these four particle. It is in tetrahedral geometry. So this is the tetrahedral geometrical shape. So therefore it is known as tetrahedral void. So the in between the four particle, the small space remains. This is in tetrahedral shape. Okay, I think all of you understand this concept. Okay, in three-dimensional view, it clears the doubts of your based on these tetrahedral voids. Okay, next we move on to the second type of void, that is octahedral voids. This octahedral void is also known as ovoids. Generally it is known as ovoids. Then how octahedral void is generated, and when or what type of packing that leads to octahedral void? let us discuss. Before that, octahedral void. The meaning of octahedral void is it is a space, empty space, octahedral space that is created by the particle during the packing. Simple definition: the during the packing of the particle or joining of the particle, empty space remains. Suppose the empty space is octahedral in shape, then it is known as octahedral void. When octahedral void is possible, formation of octahedral void is possible. It is possible in during the ABC type of packing. ABC means cubic close packing, CCP. The CCP packing crystal contains small portion. It is FCC, face centered cubic unit cell. That means octahedral void is mainly observed in face centered unit cell. Okay, this is a very important concept you should remember for your competitive exams. Okay, and these are the first layer and the second layer and the third layer. It is entirely different from the this one. Okay, so or the blue sphere is represent a second layer, red spheres represent third layer, and the first layer uh, behind sorry bottom of the blue particle, or the first layer you can consider it is above the red spheres. Okay, you can consider the particle on this place or behind this place. Okay, this same. Okay, so covers the this hole is known as octahedral voids or octahedral space in three-dimensional view. Okay, this is the three-dimensional view of the octahedral particles. So or sorry octahedral voids, the particles are arranged in this manner. Okay, one particle sphere is in this part. Okay, next these are the three. When we join these three particle or join the centers, then we get triangle. The triangular base is toward the screen and the point represent the away from the screen. Just observe the another layer. When we join the centers, point is towards screen and the base is away from you, opposite to this one. This layer is opposite to this layer. Okay, these are the B and C layer. Where is A? This one, first layer. There is a one layer is present. Okay, this particle the particle of A is placed in this area. That means cover the holes between these six particles. A, B, C, again A, B, C type of arrangement. Okay, I think all of you understand the octahedral void concept. So the space is look like this one, octahedral space or octahedral void. Okay, this is the octahedral void. Okay, then the very important concept is calculation part. How there is a one relationship to calculate the number of voids. Then what is the relation? The relationship between the number of particles in the unit cell and the voids. How many number of particles are there? Based on the number of particles, we can calculate the number of voids. Okay, the relation is number of particle is suppose it to be n, and number of tetrahedral void become 2n, twice the number of particles. Tetrahedral, how many tetrahedral voids are present in one unit cell? How many particles are there? Twice that the number. Tetrahedral voids. Octahedral, how many octahedral voids? Same that the number of the particle present in the unit cell. Okay, then calculate the number of particles. In FCC, how many particles are there? You already calculated in the previous video. Number of particles. Number of particles in FCC is 4 particle. In one unit cell, there is a 4 particle. N become 4. Then how much? Tetrahedral void. It is 2n. N is 4. Therefore, 2n will become 8. Tetrahedral void is 8. Next, octahedral void. Octahedral void is n number. N is 4, therefore octahedral is 4. BCC. BCC number of particle is, you already calculated, number of particle is 2. Number of tetrahedral is 2 into 2, 4. Next, octahedral wide is number of particle. Number of particle is 2. Therefore, octahedral wide in BCC is also 2. Okay, this is the very important chart you should remember for your exam to solve the problems or to calculate or determine the molecular formula. For that purpose, this concept or this relationship is very important. Please remember this relationship. This is about the voids. Once again, we look about the voids in different unit cell, and first consider the uh, tetrahedral voids in different unit cell. Okay, tetrahedral void is, this is the tetrahedral void. The particle, actual shape of the particles is like that. Okay, this is the actual shape. So this is the tetrahedral void. In all the direction, it look like this one. So we can see the tetrahedral void in all direction. Okay, the first three particle create triangle empty space. The triangle empty space is covered by the another particle. So the space, empty space, is look like tetrahedral shape. Okay, how it is? Yes, this is the tetrahedral shape. Empty space, this is the tetrahedral void. Okay, in primitive unit cell, the tetrahedral void is like that. Okay, there is a one tetrahedral void because so two tetrahedral void, because number of particle is 1 in primitive unit cell. There are two tetrahedral voids are possible. I am represent 1. Okay, in the primitive unit cell, one tetrahedral void is observed in this manner. Okay, next we observe the tetrahedral voids in face centered unit cell. How many how many tetrahedral void in FCC? You already observed one chart. Yes, it is. Number of particle in FCC is 4. Therefore, tetrahedral void is 8. How it is 8? In each corner, just observe this diagram. In each corner, there is a one tetrahedral void. This is a one, I am considering only one corner of the cube. When we join the center, I am joining the center of the particles. We observe the tetrahedral void. In each corner, there is a one tetrahedral void. How many corners are there in cube? Very good. It is 8 corner. How many? Then how many tetrahedral void? 8. So in the calculation part or in the chart also, it clears that there are 8 tetrahedral void. Okay, we observe that one tetrahedral void in one corner. Next, in another corner, there is a similar type of tetrahedral void is observed. There are 8 corner. Therefore, 8 tetrahedral void is observed in one FCC. It's a very important thing you should remember. Okay, 8 tetrahedral void is observed in FCC unit cell. Okay, next, octahedral void. Okay, octahedral void. How octahedral void is generated? In ABC type of arrangement, the octahedral void is observed. So this is the octahedral space created by the particle. So in the animated video, it clears how this arrangement is observed. Okay, one triangle is, the base is towards you, another is opposite to you. This is the arrangement of particle, and that creates the octahedral void. Okay, just we observe once again. Suppose it is a B layer. The blue color ball is B layer. Then red color spheres are represent. Very good. It is represent C layer. Okay, A layer, B layer. This is a blue color spheres is B layer. Red color C layer. I am represent again A. This is the A layer particle. Particles in A layers. Okay, the middle spheres covers the empty space of the B layer and remains empty space on C, and again A. The sphere particle in A layer covers it, the sphere. A covers the space, and B and C create the space. This is in ABC type of arrangement. So this is the tetrahedral, octahedral void observed in ABC type of arrangement. Let us observe the octahedral void in face centered unit cell. Okay. Yes, this is the face centered unit cell. In this face centered unit cell, how octahedral void is observed. Okay, I'm consider the body diagonal. Remember the body diagonal. We are going to observe the octahedral void. Therefore, body diagonal is considered. Okay, this is the particle at one corner. It is considered as A, particle present in A layer. Next, I am represent the particle present in B layer. One right angle triangle is created. So when we join the centers, next the another layer, it is C, which is the particle present at the face creates this one layer C. ABC type of arrangement is observed. Okay, clears. In suppose you are not clear in this concept, then again once again we observe the octahedral in body diagonal. Okay, I'm considering only one body diagonal. How many body diagonal in cube? Yes, there are 4. Okay, I am represent only one. ABC. So it's a body diagonal. The particle present around the body diagonal that creates the octahedral voids. Okay, this is the important thing. Clearly observe this animated video. This is the one body diagonal. It creates one space that is octahedral in shape. Another one, and the another body diagonal. How many body diagonal? 4 body diagonal. So there are 4 body diagonal in unit cell or cube. Therefore 4 octahedral void is present in face centered cube. Okay. In the calculation part also we observed there are 4 octahedral, 4 particle, therefore 4 octahedral void. I hope all of you are understand the concept of tetrahedral and octahedral void. Suppose you are have any doubt, please contact me, and suppose you, it not clear, just once again you view all this video. Okay, then please subscribe our channel. Thank you for watching this video. Please subscribe and press the bell icon for get early notification of our videos. Thank you once again.